Okay, let's resume. We are done with the algebraic preliminaries and some exercises which include rather complicated nonlinear inequalities. And then let's talk about geometric preliminaries. We have lines, and standard equations of lines are here. Slope-intercept equation, when slope m is the slope, and then 0 comma b is the what do you call y-intercept. And then slope point equation is here. Slope is m, and then the line is running through x naught comma y naught. And then if we have 2 points, then you can use slope m equals to rise over 1, y2 minus y1 over x2 minus x1. So put those into slope point equation, and we end up with a second equation down here. That's the equation of a line when 2 points are given. First point x1 comma y1, second point x2 comma y2. Okay, this next example, what if we have parallel lines and perpendicular line? I'm not going to talk about perpendicular line, just parallel lines. Parallel lines share the same slope, so it has to have the same slope as the second line, 1/2, and then running through negative 1, 3 comma 1. So plug it into slope point equation, which is this equation over here. So m is 1/2 minus of negative 3, so plus 3, and then plus y naught, so plus 1 here. So here goes what do you call this parallel line. Perpendicular line, you have to use negative reciprocal as the slope. Exceptional case, horizontal or vertical line. Horizontal line is y equals to b. Vertical line is x equals to a. And x equals to a, you don't have y, so there is no slope. Y equals to b, there is slope because this is same as 0x plus b. Slope is 0. In this case, slope is undefined. And let's move quickly. Circles, we can find out the distance between 2 points using the distance formula like this. And you can find out through Pythagorean identity, as a matter of fact, the difference of x coordinate is horizontal, the difference of y coordinate is vertical, and horizontal squared plus vertical squared is hypotenuse squared, which is distance squared. Here we go. And taking the square root, we have the distance formula. So everything is just coming from a Pythagorean identity, to tell the truth. Now, if I apply distance formula to analytic geometry, then we can get a circle. X naught, y naught is the center, and x comma y is an arbitrary point on the circle. So from that circle, I draw a radius, as you can see in this picture. Lower top left-hand side corner is arbitrary point x comma y, and the distance between x comma y and the center, x0 comma y0, is r. So we have the distance formula. Taking the square, we have an equation of a circle. X minus x naught squared plus y minus y naught squared equals r squared. And in general, for more complicated case, we can have relationship between x and y, which may turn out like a curve, kind of like this, kind of wild curve. And then if you have more than one curve, then the crossing points represent system of algebraic equations. So we have first equation and the second equation. And the first equation is, yes, the blue one, blue curve. Second equation is red one, red curve. And then we have crossing point, 1, 2, 3, 4 points where these curves cross each other. And we can actually find out those crossing points using mathematical program like this. But if you're not really interested in computational aspect of this course, then never mind about that. Okay, so far so good. Let's quickly move on to analytical preliminaries. where we have to discuss variation. We can have variety of variables, and those are characters, and those characters can be interrelated, and how they change, how the change of one character is affected by another character or other characters in plural is called variation. For example, here's an equation PV equals to nRT, which appears in chemistry. Here we have direct variation between volume and temperature, and because we can divide P away, so V equals to nR divided by P times T. So nR divided by P can be considered as a constant, and V and T are proportional. So T is doubled and V is doubled. Temperature is doubled, and then volume of a gas is doubled when everything stays the same. And in this kind of situation, which appears in physics, this gravitational force is G times m1 m2 divided by r squared, and F is inverse proportional to r squared. So r is doubled, then gravitational force becomes 1/4, and r is tripled, then gravitational force will become 1/9. And those kind of things are relations, and those kind of things are variation. Let's go through these with an exercise problem like this one. Variation. Okay, how about this problem? No, too complicated. 4.4. This problem. A volume V of a mass of gas varies directly as the temperature T and inversely as pressure P. If a kind of gas has volume 16 cubic inches when the temperature is 320 degrees Kelvin and the pressure is 300 pounds per square inch, find the volume when the temperature is 350 Kelvin and the pressure is 280 per square inch. This kind of problem is called variation problem, and it kind of goes like this. Step 1 is to get an equation finding out relationship between V, T, and P. So V is equal to variation constant K is necessary and varies directly, so T is multiplication, and then says inversely with pressure, so this is gonna be division. So there goes a variation equation, K times P over T. I said it backwards, K times T over P. That's step 1. Step 2, let's go over the second sentence. And we have to identify K value from the second. So 16 cubic inches, so volume is 16, and K times, and then temperature is 320, and then divided by pressure is 300 pounds per square inches. And from this, you can find out what K value is. And what is it this time? It turns out the K value is 15 in this case. Okay, let's put 15 there. And the detailed computation is left to the student. That's step 2. Let's recap what we did. First sentence gives you a variation equation. That's step 1. Second sentence give you K value, that's step 2, and then the third sentence is the answer to the problem. Find out the volume. We have to find out the volume when K is 15. In this equation you have to plug in K equals 15, okay, times volume is, now temperature is in 350 Kelvin, 350, divided by pressure is 280. And all you have to do is calculate this one using your calculator, and you have the answer. It turns out 18.75, and that's going to be the answer. This kind of problems are variation problems, and typical, pretty typical. We have 3 sentences. First sentence, variation equation. Second sentence, K value. Third sentence, well, final answer to the problem. Problem like 4.5 is a little bit tougher, but I'm going to leave those to students. And then problem 4.6, I de-emphasize because it tends to be a little bit more complicated, but if you're interested in astronomy or physics, then maybe you can read about it. So analytical preliminaries variation part is done, and I'm going to spend rest of the time talking about some equations when we have to consider extraneous solutions. Let's consider this kind of rational equations, and how do we deal with this kind of thing? Well, the very first step is to kill off all the denominator simply by multiplying this big one, which is actually x plus 3 times x minus 1. What am I talking about? After factorization, the middle denominator is actually first denominator times the last denominator, so multiply that to each term. So the first term and the second fraction, and then the third fraction, we just multiply those, and then cancel. Do you see cancellation? This x plus 3 and that x plus 3 cancel out, and no denominator here. Everything cancel out here, and then we have 3x plus 1 there. And this x minus 1 and x minus 1 in the middle cancel out, and we have something like that. So we have a polynomial equation now, no denominator. Solving it is easy. Break up all the parentheses, foiling it, whatever, and then solve a quadratic equation by factoring, and we got x equal to -2 and x equal to -3. And be careful, do not stop here, because this polynomial equation, or where we started over here, is not the same as the original equation. They're certainly related, but not the same. So you have to check whether these solutions are actually real solutions or bogus. Plug those in, and you'll see that x equal to -3 is bogus, and you can easily see that because -3 in putting -3 in place of x, you're going to get 0 in denominator. So x equal to -3 is bogus or extraneous, and we have to say the answer is x equal to -2. And I just wanted to remind you of this algebraic manipulation of killing off the denominator and also checking for extraneous solutions. Okay, let's go quick, and let's move on to one square root problem. If there's only one square root, kind of like this, it's relatively easy. Square both sides, square root in the left hand side will be gone, and the right hand side will be a complete square. Now, what if you have something like this? If you square both sides, well, that's not going to work. I mean, if you try, you'll see. If you try complete square formula, you'll see. So what do? Isolate one square root and square, kind of like this. So for one square root, move this square root to the other side, and what you get? This square root equals to that one. Square both sides, and left hand side, square root and square root cancel out, and we have just polynomial factor. Right hand side, on the other hand, is a complete square, so we have, well, ugly square root term still shows up as a middle term. But that's a step up because we used to have 2 square roots, now we are down to 1. So solve for this square root, as you can see, this one and then that one. So for the square root, and then if you square this one again, then left hand side will be complete square. Right hand side will be square root squared again, so square roots will cancel each other out. Precisely speaking, 4 squared is 16, and square root of 2 minus x squared will be just 2 minus x. So what do we have? Quadratic polynomial, equal to this linear polynomial. We have ended up with a quadratic equation. So quadratic equation and a factor to solve it, and we have 2 candidates, x equal to -4 or x equal to 7/4. Are these okay? Well, you have to check. Always check for extraneous solution. Put those back in, and you will see one of them is false and one of them is okay. So x equal to 7/4 is a legitimate solution. X equal to -1/4 is a bogus one. It's an extraneous solution. Be sure to check for extraneous solution. Also, please remember about this getting rid of square root by isolating it and then squaring both sides. In this case, you have to do it twice.